Hey everyone, so I'm just gonna make a short little video about forces for those of you who really need it. So first, when we do this, we need to start by defining what a force is. A force is an interaction between two objects. Now you're probably thinking, what does that mean? Well, as I pretentiously decide to explain, there are basically 4 different types of forces. We'll go into more detail about them later, maybe. So first, probably the most common one that we learn about is gravitational force, which is notated as Fg, usually in context to Earth pulling on objects close to the surface. There is normal force, or a squish force. And it is called this because it is basically a push. Like when I'm pushing on the binder right now, that's a normal force because I'm squishing the area in between the electron clouds in the atoms. So that's why it's called a squish force. And that's when there's pushing, and it's notated with Fn. There is also tension force, or a stretch force. And this is when you pull something, like if there's someone else pulling on the other end of this pencil, that would be a tension force. And it's called stretch because you're stretching the electron clouds in between the atoms. And that's notated Ft. And then lastly is frictional force. There are many different types of this force, and it's notated as Ff. Frictional force is a resistive force where contact between two surfaces causes deceleration, even though technically we're not allowed to use that term, deceleration, because as we will find out in Newton's first law, basically outlines 2 main ideas. One, an object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity. And since velocity is a vector, we can imply that velocity also refers to direction and speed. And this is all only true when net force is 0. And this is either when there are no forces acting on the object or all of the forces cancel out. So, however, when there is a force, then there is always acceleration, but we don't need to get into all of that. One good example is if when I drop the pencil, it accelerates downward because it starts at a constant velocity of 0, and then it is being the force of gravity downward, but it's also being stopped by the normal force in my hand. But as soon as that's gone, it falls because the gravitational force pulls it downward, and it accelerates downward. So more about frictional force. There are many different types. There is a non-moving frictional force and a moving frictional force. Now, a non-moving frictional force is usually characterized by sliding. So like this would have frictional force. This rolling does not have that. So a moving frictional force is when a specific part of an object is repeatedly being exposed to the surface. However, a non-moving frictional force is when that is not true, because probably not the best example with a pencil, but with, say, a ball, when it's rolling, there's always only one point that is directly in contact with the surface, at least when it's a perfect sphere. So you can say that technically there is no actual moving friction, because there's no one point on the sphere that is moving in relation to the surface and constantly being in contact with it. That is not true if say you had a cube and you slid it, because then there'd be moving friction, because the bottom side of the sphere would consistently be in contact with the ground. But that's mainly just a semantic difference, and you don't need to focus much on that. So net force is represented by the symbol sigma F. Sigma because it means sum of, and F because it's the notation for force. And when this equals 0 is when this is true. And yeah, a lot of the other things just come out of this from kinematics. So you know, in kinematics, motion in the x direction is completely independent from motion in the y direction. Same thing is true for forces. Forces in the y direction are completely independent from forces in the x direction. Though usually the forces, if they're at an angle, there's an x component and a y component. So for example, if there is say a tension force this way, then what you would need to do in order to deal with this force, you'd have to split it into a triangle, and you would have to know one of these angles. Let's say this is theta, then you'd have to use trig, and using trig you know that this vertical force is Ft sine theta, and then this one is tension force cosine theta. So I'm going really fast, so just don't feel too stressed out if it isn't coming quick, because it'll come faster once you start doing problems with it. But objects, if there's a force in one direction, it cancels out a force from another direction. This is what we call a motion diagram, a force diagram, and where this is the object, and then you draw forces in all directions. And for each one, you don't denote which type of force it is. So say there's a book on a table that is sliding due to someone pushing it, then this would be force of gravity downward because of Earth, on the book by the Earth. Then this would be normal force on the book by the table. Then this would be, you would have those equal. So you use equality markings. This would be the frictional force of it as it's going that way because of the moving friction. And then this one would also be normal force. Sorry for the sloppiness, because normal force because it's being pushed that way. If it was being pulled that way, usually by a string, which is what usually causes tension force, and this would be Ft. So simplistically, this is just a book at rest on a table. It has the force of gravity on it and the normal force of on the book by the table, and the gravitational force on the book by the Earth. So since the book is not moving, we know that the net force is 0, and for that to be true, these need to be equal because they're in opposite directions, so they cancel out. And we can write this through f of x, sigma f equals Fn plus Fg, and because it's not accelerating, we say that it's equal to 0, so we say the F normal force equals negative Fg. And there's also, to find out the force of gravity, we use, sorry, if this is going fast, I apologize, but we have a lot to get through. So this is Fg equals mg, and this is the acceleration downward of objects close to Earth, which well, acceleration would be 9.8 meters per second squared, but this is the force. And here you take the force is equal to the mass times the strength of Earth's gravitational field. And on Earth, close to the surface, that is, 9.8 newtons per kilogram. So, to find out the force of gravity, you need to multiply its mass by this strength. Force is measured in newtons, by the way. One more thing. Oftentimes, when you're solving problems with the object at rest, you'll have to use a force equation. And this is very important because oftentimes force equations have their own points on the AP exam. And often you'll have to do it in multiple directions. So say for this one, say they wanted you to find I don't know. I'll just draw the equations. So then you'd say that Fy, because it's in the y direction, would be Fg plus Fn. And because it's not accelerating up and down, because it's staying at the same, has no motion in the y direction, then you say this is equal to 0. Then if you needed to find one of these, you can use that. Then this is that of x, and you can say that the Fn plus Ff. Now, we don't really know if it's accelerating or not. If it's at a constant velocity, we know that means the normal force is the same as the frictional force. And then we can say this equals 0. However, if it's accelerating in this direction, then we need some way to find out what that force must be. So let's say that, for example, this object is accelerating that way at a speed of 5 meters per second per second. Now, for this, we'll have to use Newton's second law, which is that net force equals mass times acceleration. And because this is net force in the x direction, we know that this equals ma. We would need to know the mass of the object, so let's say that it's 5 kilograms. So since we know that the object is 5 kilograms and is moving at a speed of 5 meters per second, we know that the net force in the x direction is 25 kilograms meters per second, or 25 newtons. This is another notation for newtons, by the way. That'll be very important later when we get into momentum. So overall, that's a pretty good overview of forces. There's obviously much more detail to go into, but since you guys haven't started forces, I figured this would be nice. So, yay. Let me know if this is helpful.